here's our review guide. This should help for the test. The test isn't any harder than this. Here's the rule we're testing on this one, how to multiply radicals. And the rule is they have to have the same index. So they have to be both square roots or I don't want to multiply those things together. When right, 50 is 25 times 2, which is the square root of 25, which is 5 root 2. I simplify the root 8, and I think of it as a 4 times 2. I can square root the 4, so that's 2 root 2. And then on the outside, I get 5 times 2, 10. On the inside, I get 2 times 2, 4, which is 10 times 2, which is 20, that way. Either way, you get the same answer. 8 to the negative 4/3 here. So right away, I would change this into radical form. Now, this is 8 to the negative 4 power, like this then. So the little 3 here, that means, hey, I want a cube root, and this means I want to raise it to the negative 4 power up there. So the cube root of 8 is just 2, so it's 2 to the negative 4. Negative exponents mean put me in the denominator. That's 1 over 16. And we're done with that guy. Let's see here. I guess I should have been putting these in the answer spot. Here comes number 3. Hey, I'm under the radical already. I can just simplify in here. So 54 divided by 2, 27. Here I've got w to the 6 over w to the 3. So those I subtract exponents. W to the 3. Here I've got a negative exponent, so I'll just put him in the numerator. So, remember, the rule is this: 1 over a to the positive m equals a to the negative m, or 1 over a to the negative m would equal a to the positive m. You're actually doing the reciprocal here, and when you do the reciprocal, you have to change the sign on your exponent. That's what it means to do. And I'm cube rooting stuff, so I'm going to go ahead and write everything as cubed so you can see them all. Like 3 cubed is 27, and w cubed v cubed. So I'm just uncubing all those things, and I get that for my final answer. Let's see here. Ooh, like radicals. Interesting this. It says, hey, if the radicals are exactly the same, then you can add them, and you get radicals. That's just how we add like radicals, like adding like terms. But these are not like terms, right? They don't have the same meaning, same radical. And so we really can't subtract them. But we can still just simplify it. So this, cube root 256. And I know 256 is a power of 2. So I'm just going to write down some power of 2. 16. There's 5 is 32. There's 6 is 64. And 2 to the 7th would be 128. And 2 to the 8th would be 256. Alright, so this is 2 to the 8th power in here. See, this other one's just 5 cube root of 4. Now, I like this to the 8th because, see, remember, I can break this up and say this is like a 2 cubed. Well, actually, it's like a, yeah, we'll write it that way. 2 cubed times a 2 cubed times a 2 squared. Okay, why did I do that? This is 3 plus 3 is 6, 7, 8. This is still 2 to the 8th power under there. But every time I have 3 of a kind, a 2 gets to come out. So 2 gets cubed, 2 cubed gets cube rooted, giving me a 2. That happens again right here, so that gives me a 2. So I have on the outside the 3 that was already there. Out come the cube root of a 2 cubed. Out comes a second cube root of a 2 cubed. And then I'm left with this 2 squared on the inside. So it looks to me on the outside like I've got 3 times 2 is 6 times 2, 12. Cube root 4. Minus 5 cube root 4. Big 5. Cube root of 4. And 12 minus 5. See, now they're like radicals. And that just happened. When I simplify it, it turns out they're both cube roots of 4. So now I can add these, or in this case, subtract them. 12 minus 5. Give me 7 cube root of 4. And that's as simple as I can go. Can't cube root of 4. You can square root it, but it doesn't want that. All right, solve these equations for x. It doesn't say anything about domain and range, but I always like to find it when I'm doing radicals because, well, it turns out that tends to be important. If not at this moment, later on it will be. So here I have to divide by a negative 3. And that tells me my solutions have to be, I flip my inequality, less than 19/3. Or approximately, let's change this to what? This would be 6 1/3. So 6 1/3 or 6.3 repeating. So any answers I give have to be less than that number. So let's go ahead and solve it. All right, so for radical equations, you have to have whatever radical you're trying to get rid of alone on one side, isolated. So here's our equal sign. On the right side, we just have a radical by itself. When you're like that, you just undo the radical. In this case, it's a square root, so we square it. So here's my x minus 3 times x minus 3. That's what that side means. And the other side, when I square it, it eliminates the radical. The rest of this is just all cranking through it. I'm going to do that multiplication pretty quick. I'm going to recognize this is a quadratic equation, so I want it equal to 0, not all that junk. So I'll add my 3x and I'll subtract my 19. So now the right side is 0, but I got to do the same thing over here. I line up like terms, and I get myself an x squared minus 3x minus 10. Let's see if that quadratic here factors for us. Hopefully it will. X and x, they got to multiply to 10, so 2 times 5, and they add up to 3. There we go. So x is either -2 or x is 5. Let's see, both of those things are less than 6 1/3. Now let's check for extraneous solutions. So I start with my original equation. And all I'm doing is checking my answers to see if any are extras. So I plug in the -2 here, and I go -2 minus 3 is -5. And I know now -2 is extraneous. The reason I know that is when I put that -2 in there and get -5, there's no way I can square root something and get a negative answer. Okay? Square rooting always gives me a positive, or imaginary sometimes, but not -5. So the -2 isn't going to work. So then I try the same thing, but I use the 5, and I go 5 minus 3. Oh, that's 2. So that's what the left side equals. How about the right side here? Be the square root of 19 minus 3 times 5. That'd be 19 minus 15, the square root of 4, which is 2, and it checks. 2 equals 2, so I know x equals 5. 6, radical equation. In fact, this one's got 2 radicals. 1 and 2. But they're both isolated. So while I'm trying to just maybe get rid of the left one by squaring it, it also gets rid of the right one simultaneously. And I should have found my domains first, but they aren't really asking for it, so it turns out it's okay to just solve them and then check them. Let's see, plus 5 equals 7, so x equals -2. Let's check to make sure that's not extraneous. It would be 2 times -2 plus 5. Does that equal -2 plus 7? So this would be what? -4 plus 5, which is the square root of 1, which is 1. Oh, the error, this should be +2. There we go. Let's check a plus 2 in here. There we go. That's 4 plus 5. Square root of 9. There we go. That's a 3. And does that equal 2 plus 9? 2 plus 7 is 9. That equals 3. It checks. So 2 is our solution. It's not a radical, at least it's not shown as a radical here, right? But that 3 means cube root, so this is a cube root right here. Okay, so we want to get it alone so we can eliminate it. You could switch to a cube root at this point, but it turns out to be nicer. I'm just going to add 7 to both sides. Anyway, it turns out to be nicer. Just leave it with an exponent like this, because now I can just raise it to the reciprocal power. And that's a multiplication rule. When I multiply a number by its reciprocal, I just get 1. So it's x plus 60 to the first power, which we don't show. And over here, I've got to work that thing out. It's the square root of 25 cubed. So let's see here. That's x plus 60. Square root of 25 is 5. Cube it. That's 125. I subtract 60 from both sides. I get x is 65. I am going to check that to make sure it's not extraneous. So I put the 60 into the left side of the equation. I cube root the 125 and square it. There's the left-hand side. Oops, then minus 7. I got to put that in there. So left side came out to 18. Yeah, that checks. I'm done. Pretty simple. Let's see our next problem. Now we're on side 2. Find the inverse. So I'll walk to the steps. Step 1. Finding inverse. Change f of x to y. So here's step 1. It's easy. Step 2. Exchange x and y. So I'm going to take my y, I'm going to make it an x, and I'm going to make my x and change it to a y. Step 3, solve for y. So I'm just going to undo this slowly here. I'm going to get the 10 to the other side here and then get rid of this negative half. So let's see here, I'll go x minus 10. It's negative 1/2 y. Now I want to get rid of this nasty negative 1/2 fraction. So I'm going to take this side times the reciprocal. And I'll have to take this side by the reciprocal. But you can see negative 2 over 1 is just negative 2. So I get on the left side negative 2x plus 20. On the right side I just get y. 2 times 1/2 is 2 times 1/2 is 1, and the two negatives make a positive. Alright, so I'll finish this one up and write my answer here, negative 2x plus 20. I'll move on to number 9. There we go. I'll change my f of x to y. I'll exchange my y for an x and my x for a y. I will now subtract 5 to get my x, or my y term rather, slowly alone. Oops, get that radical there. My y is not quite alone here yet. There's my dotted line coming through there. Kind of make it look like an inequality, but root y here has a 3 in front of it, so I gotta get rid of that 3. So we'll just divide by the 3. And so I'm at root y. I flipped the whole equation here, so I get that y on the left-hand side. Now I just have to square both sides. Alright, so the left side is just y, or f inverse of x. I just got to clean up this right side here. So that's an x minus 5 on top that needs to be squared, but I can just leave it like that. And a 3 in the denominator, which is 9 now after I square it. So maybe a really good answer would look like this, where I can now tell it's a translation to the right by 5 of a parabola. Alright, so now I've got my answer here. But my answer is a little concerning, and the reason why is I recognize this is a parabola. Parabolas, in this case, this would be shifted to the right by 5, 2, 3, 4, 5. It's going to be really wide, and it would look, something like this. Why is it so wide? Because that 1/9 shrinking it vertically. But this parabola flunks the horizontal line test, so it does not have an inverse. Okay? Which means, hey, if this didn't have an inverse, these two can't be inverses. So something must be going on here, and it has to do with the domain. So if I look up here at the original function and check his domain, root x that x has to be greater than or equal to 0. That's the domain of this, and its range would be y is greater than or equal to 5. It'd be up here, 1, 2, 3, 4, 5, because of the shift and going this way, the vertical shift. Okay, and so what that tells me when I start to think about this one and saying, oh, these x's only give me this half of it, not the bottom half of the parabola on its side. Okay, so this mirror image of this about the line y equals x would be over here. It's this half of the parabola. Okay, so I'm going to have to restrict that domain, so I only want this part of my answer, this part of that purple parabola, and then it would be the mirror image of the radical equation. I'm going to do it with a dotted line because it's going to cut through my purple answer there. So this is the f of x, and this is the f inverse of x down here. Okay, so I'm going to have to put a restriction on my domain here, and I'll say, hey, there's the inverse as long as I'm only using x's that are greater than or equal to what number? Well, I steal it from the range up here, greater than or equal to 5, and that gives me, there's my x is 5 right there, and I just want the x is greater than 5, which gives me that half of that parabola. Last two, I'll let you guys, well, I've got the answers there. 10 is just A, and 11 there, it's all the x's to the left of x equals 3, negative 3. And so there's our answers. It's the inverses that are the tough ones for many of us. And that should do it.